Hi, in this presentation I'm going to show you how to do quadratic regression, and after you've watched it you should be able to do the quadratic regression project. So the idea with regression is you're trying to model a set of data. In this example we have data that gives us the height in inches of water that's being drained out of a cylindrical tank. And the data shows us after various different seconds how much height of water is in the tank. So for example, it starts out with at 0 seconds you have 30 inches of water, and then after 9 seconds it's down to 25, and it continues to drain until after 79 seconds there's only 1 inch of water left in the tank. So we want to first of all make a scatter plot of this data. You can see in question number 1 it's asking us to make a scatter plot, and so we'll do that. So to make the scatter plot we'll use our calculator to enter the data in and then make the graph. So if we press our stat key and then we enter the time values into L1, and you can see I'm entering these into L1 on the calculator, and then the height values you can put over here in L2. And now we'll push second y equals, and that pulls up the stat menu, and we'll hit enter on plot 1 and we'll turn it on, and it's set to a scatter plot, which is good for L1 and L2. That's where our data is. And then we'll just do zoom. Well, before I do that, let me make sure I have no functions in there. So then zoom, and then it's number 9, which is zoom stat. And that makes the calculator make a nice picture. Now if we look at this picture, we can kind of see it's curved a little. It doesn't really follow a straight line. And in question 1 we're supposed to give a rough sketch of that. So let me just go ahead and put my axes in, and we can just kind of roughly draw the picture that we have here. Something like that. Okay. Now question 2 asks us to find a quadratic regression model for the data and give that equation, rounding all the values to the 1000th. So to do that, we're going to press the stat key, and then we'll go over to calculations, and then down to number 5, quadratic regression, and we'll hit enter. And then I'm just going to hit enter again, and we should get the model. So the equation that we want to write is y equals, and then it would be ax squared, so 0.003 x squared, and then plus bx. So b is negative, so it would actually be minus 0.606 x, and then plus c, so plus 30.054. So that's a quadratic function. That should be a parabola when graphed. Now number 3 asks us to use the calculator to graph the scatter plot and the quadratic regression model in the same window. And then we're supposed to give a sketch of that. So the idea here is, you know how before we graphed the scatter plot? Well, now we want to graph that plot again, but this time with the quadratic regression model included with that. So to do that, we'll have to enter this equation into y1. Now another way to do it is to do the quadratic regression and do vars, y-vars, function, and then y1, and that automatically makes the calculator put it into y1. You can see it's right there, and then just hit the graph. And now it's going to add that model into the other points. So we'll just put a rough sketch of that result here. We'll draw the scatter plot again. And then this time we have the model kind of going through, and we can see the model fits the points very well. Now the next question, number 4, asks us to, according to the model, how long will it take the cylinder to be completely empty? So that's when the height would be 0. So we have to set the whole equation equal to 0 and then solve for x. To do that algebraically, you'd have to use the quadratic formula. And that would work, but I'm going to choose to do it graphically because that'll be a little simpler. So to do it graphically, we will we are going to have to rescale the window so that we can see where it crosses the x-axis a little bit better, because that's the point we're really looking for. So I'm going to change my y-min and my x-max just so I can see a little farther down and a little farther to the right, and then regraph it. And I want to make sure I can get a good view of where it crosses. There it is right there. So then we'll do second, trace, and then 0, and hit enter. And then we have to give it a left bound, so we'll move it a little to the left of where it crosses, and then hit enter. And then a right bound, so move it to the right. Make sure it's on the right, and then hit enter, and then a guess, and then hit enter again. So the answer for this comes out to be 88.882 seconds. So I'll just write that down right here, 88.882 seconds. Now actually over here you can see it says a different number, but that's because I forgot to hit enter that one last time. So after that guess, you need to hit enter one last time, and then the answer will come out to be 88.882. Okay. So now let's go on to the next question. It says, according to the model, how long will it take for the water level to be 3 inches high? And we can solve this graphically or algebraically. Now, to solve it algebraically, you'd have to set the quadratic regression model equal to 3 and then solve using the quadratic formula. You'd have to subtract 3 from both sides first to get a 0 and then use the quadratic formula. But I'm going to solve it graphically because that's a little simpler to do. And to do that, we'll need to actually put the horizontal line in at y equals 3. So we'll press y equals and enter just the number 3 under y2, and then graph it. And we'll see we get a horizontal line, and we're looking for that point of intersection. So we can do second and then trace and then intersect and then hit enter, and then we can hit enter for the first curve and enter for the second, and then we move it close for the guess and hit enter again, and we get our point of intersection, and it happens at 66.916 seconds. So we can write that down, 66.916 seconds. So the next question says to use the regression model to estimate the height of the water after 50 seconds. So since x represents the time in seconds, we just need to substitute 50 in for x in our regression model and work out the answer. Another way to do this is on a calculator, and I'd like to show you this because it's kind of neat. We'll go to second, trace, and then go hit value, number 1, and then just enter the x in, 50, and hit enter. And the calculator shows you what the answer is right away. So it's 7.292 inches. So we'll just write that down here. So the water level would be 7.292 inches. Number 7 says, what is the y-intercept? So the y-intercept happens when the x is 0. So we could do that the same way. We need to substitute a 0 in for x and then work out the answer. So using this value command again, we would do second trace and then value, and this time just enter in 0 for x, and you can see the y-intercept is 30.054. So let's write that down. So when x is 0, we get 30.054. And as far as what this means in this situation, this means that after 0 seconds, meaning at the beginning of the problem, the water level is 30.054 inches deep. Now number 8 asks us, for what values of time is there a model breakdown? Now a model breakdown is when the model gives unreasonable or even impossible results. In this case, it would be impossible for the water level to be negative, and it also would be impossible for the water level to start rising again because the tank is being drained. So if we scale the window on this graph a little bit, just so that you can see what the bigger picture looks like. If I change the x max to a bigger number and maybe the y min to a little bit smaller number so we can see a bigger range of the values, you'll see that you get a parabola. Now in this parabola there are some values here that really wouldn't make sense in this problem. First of all, it looks like it dips a little negative here. Now the height of the water can't be negative. And then it shows the water would increase, which isn't going to happen either if the water is draining. So any time value past the point where the tank is empty would be kind of unreasonable in this question. And remember, the time when the tank was empty was 88.882 seconds. So since x represents time, if x is greater than 88.882 seconds, the model doesn't really make sense, okay, because the behavior of the graph after x equals 88.882 wouldn't really represent reality in this case. The other part of the model where it would break down is over here where the time is negative, because time can't be negative. Time starts at 0 and goes from there. So if x is negative, that would also be a model breakdown. Okay, so this would be the model breakdown. Simply meaning the model breaks down. It doesn't give good, reasonable answers for that region. For anywhere between x equals 0 and 88.882, though, it will give good answers. So I hope this video helped you to understand quadratic regression a little bit better, and now you can try the quadratic regression project. Good luck!